Welcome to lecture 8. This is last lecture of artificial and big data. We already had a lot of discussion through the various lectures about the AI as well as big data. And now we are going to combine AI and big data concept for topic related evolution of data-driven decision making, which is called DDM. So through this lecture, you will learn many new and very updated, lecture related or classes. As you remember that we already talked several steps, so which I'm going to show you in coming slide for AI and big data course. So for AI and big data course, we made one big topic, evolution of AI and big data, from data to intelligent decision making. Then we came to this section. We already covered section 1, 2, and come to the section 3. In the section 1, we started talk about the fundamental of data and knowledge, and then evolution of data handling. Several concepts we started there. Talk about some fundamental, some talk about the evolution of data collection, evolution of the big data. We went through the artificial intelligence evolution. After that, we little bit talk more about the big data ecosystem. Now we come to the subsection of the intelligent decision making as a data-driven decision making, DDM. So remember, this DDM is part of evolution of intelligent decision making, and this section 3 is part of evolution of AI and big data. So section 3, 2 part, we already first part cover. Now we are going to start our today lecture, which is evolution of data-driven decision making. So at the beginning, we will start talk about some basic concept related to the evolution of data-driven, like introduction, definition, some sort of little bit basic information about the DDM. And after that, we will talk about data-driven versus intelligence-driven. Many interesting topics related this data-driven decision making. One of them is the analytics. We will see evolution of analytics. Some related topic which related analytics and data-driven is a scientific paradigm. We will see how scientific paradigm change and how match with the analytics and how match with DDM. And then we see analytics in DIKW pyramid and some question and terms related that, emerging trend, future direction, and then we will recap chapter 8. So when we talk about the evolution of data-driven decision making, DDM, so this is interplay between data, algorithm, and human interpretation, mixing data and AI, data and AI, big data and AI. AI is some sort of very intelligent algorithm. And human interpretation, that would be mix of AI and big data, create that environment that makes DDM. So this is very important point. So let's start with the definition of the DDM. So before, let's back. So please pause the video and tell me what is the DDM. Pause the video and give me some definition and tell me what is the key characteristic of the DDM. How can we implement? What is the benefit of that? What is the data life cycle of that? So please tell something, what you feel, what you know about evolution of DDM. So, okay, now is the time. Let's go inside. So for actually, for definition, DDM is some sort of systematic approach for which we can extract some insight in the pyramid. Here in this part, DDM, we need to do some action. In the DDM, we use data to decision making, not experiment. Usually people use experiment and some assumption, some intuition. Usually we use that one to do decision making. But DDM leverage, some rule that do not fully based on the experience to make a decision. And see here, this is DDM is a practice of basing decision on analyzing of data rather than only experience, feeling, intuition. So we try to extract patterns of data to get some information, knowledge, and then come to some wisdom. So key characteristic of the DDM is a collecting relevant data from different channels, because we are talking about the big data, unstructured data, structured data, semi-structured data. So we collect it through like IoT devices, sensor. Then we process, analyze it using many platforms we already talk. Then extract the insights using tools we already talk, like machine learning, other things. So this is the point you need to consider. And what is the advantages if we go for DDM? There is a 3 advantages which you can focus about that one. One is the productivity will be increased, and ROA means return to assets. That is, if I explain what the return to asset ROA means, ROA is some sort of financial metrics to measure how efficient a company uses its assets to generate profit. ROA is calculated by one formula. ROA calculated by net income. You have a net income when you reduce your expenses from how much you're selling, whatever remain, that is net income, to the total asset. So total asset you have, right? Those assets then multiply to 100. For example, you have a company, net income is $200,000, right? But your asset means your the value of your company. Assets like properties, land, and sometimes some equipment which you can sell, convert to the money. There is many sort of asset like current asset or non-current asset, so which your company has. Even real estate owned by company, those is the assets. So 200,000 your net income, and for example 1 million is your assets, $1 million. This is dollar, right? Then the result would be for this example is 20%. This means for $1, for every $1 asset, you can get profit of 0.20 dollars as a profit. So based on the $1 you have, you can get 20% of that, you can get profit. So many high-tech companies, they have less assets, but their income is high, so ROI high. So enhanced properties, data-driven decision-making will be, manage, increase your ROA. So increase your ROA means your company is a data-driven decision-making. So this is the enhanced productivity. Usually by ROA, they can measure. Improve accuracy. So this reduce, any error. Enhance reliability decision. Increase transparency. Everything very clear using the data-driven. So that would be, most of the traditional decision making, they are using intuition, feeling, some sort of technique, experience. So, or let's say intuition like cognitive bias, because human intuition, feeling to make a decision. So overcome means manage this problem. Cognitive means related to your thinking, your feeling. Let's do this. But data-driven said, don't decide based on that one. Based on the AI and big data combine to use AI-driven, and then you cannot remove the intuition. So best case means you keep your experience plus data-driven together would be the best. So what is the benefit? We already explained. Simply enhance productivity, transparency, and data-driven culture. And that would be new culture. Not only decide based on your experience. Many companies decide to change their decision-making culture. So, as I mentioned, best is blending, integrating intuition and data together. Using the advanced tools, focus to the ethics, especially, privacy issue. So this is the, point which you need to think about. Let's talk about a little bit data life cycle. Like data life cycle, what the data happening. So we need to data a collection source of IoT com data from many sensors. You need some storage, big data storage management. We already talked, like use the Hadoop, and then do some analyzing, processing and analyzing using the Spark. Apply some algorithm to identify and extract the patterns. Visualize using the great visualizing tools. And finally, come to the decision making. This is the data in the decision making process circulating. And machine learning rules is here. AI is here. Let's see next slide. The role of AI would be here. We have a data, AI, and human judgment. So algorithm process data uncovering trend, human interpretation. This provide the context, ethical consideration. This would be, so formula would be data, algorithm, and human interpretation. So this is the DDM. So please remember this one, this formula. So at the beginning of this semester, we try to focus about these two parts, data algorithm. But in the DDM, human interpretation play very important roles. And AI try to use natural processing language, robotics, many issue related that one. Means can process the human, words. Typing, language of human, sometimes voice, sometimes video, sometimes text, as all is the natural language. Then you need to extract, and then AI or ML is try to get and improve that one. For example, like Netflix recommending 80% its streamed content based on the user preference and attention to the users and human interpretation. So this is a very important part which you need to consider. Okay, let's go to little bit evolution of the DDDK and see in the history what happened. And we want to see from long time ago how the decision making, because during these classes many times we talk about the evolution of AI, evolution of the big data, evolution of data, evolution of the algorithm. Now let's talk about evolution of the DDDK. So evolution of the DDK early started decision-making process rely on qualitative information such as human judgment and experiment, gut feeling. Do you know the meaning of the gut feelings? So gut feeling, if I explain and give you some example, this gut feeling refers to intuitions, thought, and instinct that come without conscious reasoning, often guiding decision or judgment. It's when you just know something without being able to explain why. This feeling often stems from subconscious processing of past experience. Let me give you one example. For example, in decision making, gut feeling means you meet a business partner and even everything seems fine on paper. You have a gut feeling that something isn't right. So you decide not to proceed and sign, for example, contract. In everyday life, another example, you are about to take a certain route home, but your gut feeling tells you to take a different one. Later, you find out there was a major traffic jam on your usual route. Or in a relationship, you meet somebody, you gut feeling that you don't have a good, feeling, then you cut relation. So gut feeling looks like intuition or instinct or some consciousness. So mostly early decision process related on this sort of gut feeling experiments. But over time, technological advancement have enabled systematic collection, storage, and processing of the, see here, here is a qualitative information, and here is a quantitative information. So quantitative is based on numbers. Since AI and big data are not available, we just use only our gut feeling. So regarding some quote organizations that are data driven are this mentioned by McKinsey 2022. He remembered that around the 1950 he invented and he suggested artificial intelligence and machine learning. You remember, right? Name. That scientist mentioned that organization which work based on the data driven 23 times more likely to acquire customer, 6 times are likely to retain customer, and 90 times more likely to be profitable. So who use the data-driven decision process? So how this Dddm revolutionized decision making? That was transition from reactive decision making. Reactive means response to issue after they occur. To proactive. Proactive is good. Proactive means, some person is reactive. You hit, he will answer. You will ask, hey, please bring some food, bring. Or some student, you will ask, do this assignment do by that student. This means reactive. But proactive student means, before I ask, do more exercise for exam from few weeks before that student preparing. and they're ready for that exam. Or for example, next semester, before the semester start, a student will prepare proactive student. And predictive or proactive means predict what's going to happen and prepare. Anticipate means predict the cases and good strategies. So this movement happened from the reactive to the proactive. So data-driven decision-making, DDM, is a proactive. So the integration of data, big data and AI to proceed complex data set and provide actionable insight. This is the important point of our lecture. Why? Many people ask why the name of this class is Big Data Artificial Intelligence or AI and Big Data. And even maybe when I was trying to prepare these classes, when I search in the word, mostly they focus either AI or Big Data. You can find less classes combining of the Big Data AI. Why? Because it's very difficult to teach combination of this class. You were witness how I spent time for this class to manage properly, and I suffer a lot. Too many concepts, and I have a limitation also for the student who they don't have a background of computer science. Many other challenges like that. Plus, main challenges, how to integrate AI and big data and teach properly. But because it is very important, integration of AI and big data will be back to the best data-driven decision-making level. So that's why it's very important. So that's why now I feel good and you feel very good. You know about the big data and artificial intelligence, because integration will be actionable insight more than intuition and gut feeling. So this is the point. You now understood why integration of big data and AI is very important. Okay, let's see now from data point of view this evolution. Now I talk about the introduction of evolution. Later I will talk about the data and key milestone and more detailed one. So from data point of view, if you see this evolution before data-driven decision rely on intuition, gut feeling, some sort of guessing. Retailer order inventory based on the personal experience. I feel based on the 10 years working, we need to do this. Most of the time they fail. And later on, they come to the earliest stage of data utilization and try to utilize the data. Start from the Excel file, 1918. And then try to emerge basic data management system or DBMS. And later on, big data come from 2000. Many data, because we have many data, shift from collecting of the structured data to analyzing unstructured data. So this is the from the data view. And let's from some key milestone. So key milestone, if I try to mention that image of the DB around the 1970-80, which is SQL-based RDBMS. Already I explained relational data, which is based on the structural data. And then some tools, BI tools come, 19. So 1990, BI tools, some deeper analyzing and visualization. Then era of 2000 big data come, some distributed system like Hadoop, Spark, some streaming data, and then AI and predictive from 2010, integration of machine learning and big data together used for many applications like Netflix. Now let's go for detail, evolution, which more detail of history, what happened during the history. So this is, here you are. Very nice. I spent too much time to create for you. And as a very nice reference for evaluation of, how happened through the data-driven decision making. Which start, before 120 years ago, use basis statistic and using the early census for the government decision. And early 90 to 50 years back, later, use the like time cards mechanical system to record worker data and doing very statistical analyzing. And then come to the commercial computer, personal computer, between 50 to 17. Use of mainframe computer and inventory management, development of the decision support system. 1970 means 20 years later to 4 years later, relational data. And the BI, 1990 to 2000. BI, like the DW, remember, we already discussed in big data, OLAP tools, which is based on the data warehouse. For, dashboard interactive report, it was around 2000. And web e-commerce, that is based on the online behavior, decision making based on online behavior. And big data and machine learning from 2010 to 2020, and automated AI and decision making area from 2020. So advanced recommendation system using the AI like Netflix. And another, after this revolution, ethical issue coming to the concern, and many new technology like edge computing, quantum computing come to the evolution of data-driven. So let's see what is the key difference between this evolution of the data-driven decision-making and other. So this is a start from here. This is a key difference, so we already put here, no need that one. So the key difference between the AI and others, when you see in the history, with the other previous one, the key difference is focus on decision making. So in the DDM, focus how data is used to make a decision. So other categories are more about technical evolution of data handling algorithm. But this is specifically how data is used for decision making, but the other using for technical issue. Interdisciplinary, Dddm, combine element from data practice algorithm, but other category focus about their specific domain without showing the combined impact on decision making. From business and organizational perspective also, so impact to that one, human factor. Human, this DDM, less attention human, and use it, but plus data-driven analyzing. Ethical, data-driven often include discussion on ethical use of data and privacy issue. The other category touch in this issue, but they are not typically a central, focus. So application-oriented, more application. So in terms of chronological milestone, while there is some overlap in timeline, data-driven focus on milestone. Milestone for what? For decision made. Chronology. Chronology is related to arrangement of event or dates in order in which they occurred. For instance, I create a chronology of my task to better manage my day. This means organizing tasks in order, they will be completed. So make an order for my task, chronology. So this timeline, the data-driven, mostly focus, if you see the timeline, is decision-making, but the other focus in their respective field. So a scope of the DDM is different. Intuition of multiple discipline, which there is combination, and future trend in the DDM focus how how a decision will be made. In other category, future trend are more about the technological, only focus about the technological, not about the decision. Okay, after this, we need to little bit talk about the data-driven and intelligent-driven, and then start evolution of analytics. Okay, data-driven versus intelligence-driven. Let's look at DIKW pyramid. So when we talk about the data-driven, so this refers to the decision-making process that rely on primarily on raw data and historical analysis. It's about collecting data. You see only data, understand the event. But intelligent-driven, this focus on the leveraging advanced analytics, such as machine learning, to anticipate future event, optimize decision. So data-driven, simple data-driven, or intelligent-driven. So if you see the pyramid, I made this by myself. So look at here, very nice figure you can see. You remember about the big data or contextual synthesis, we already talked about the algorithm. So mostly focus about the data. Here also is the data, but I call it intelligence driven. But basically the data means some sort of very intelligent data. So this is also data driven, but more advanced one is not, data is mature. Here, you can easily, achieve that one. And then you will see later. So this part we will talk in the analytics, descriptive, diagnostic, and predictive and prescriptive analytics. And when you go, the intelligence increase. Here is a less intelligence. Data is a raw data. And then when you go here, intelligence increase dramatically. Wonderful. So then we already talked about that one. What happened here? Detected, connected. You can see synthesizing, executing. Many questions. What the best course action? What the impact here? So you can read. So here, this sort of, here is, if you see, more data should have some sort of maturity compared to this sort of question. Okay, you can pause and read more. Time is short, I have to pass. So in the data-driven, we will collect it at the first part. We focus entirely on collecting data. Decision in this stage are primarily based on the availability and quality of data collected. It is purely about the gathering. But later on, we organize data, understand what happened. What happening here. So this is a heavily on a descriptive analysis. This is describe, is a very basic. And this is based on the descriptive analysis. And explain past performance. Data is structured and visualized in a way drive decision. Later on, contextual. We ask why. In the contextual, why will be started. But here beginning of the Y, and then big Y in the wisdom. And here, data-driven, we will shift to the intelligent process. Is a predictive. When we predict, we will do based on some intelligence. What will be happen? And in the last optimization part, this is prescriptive and what action should be taken. This is the important things in the decision making. Okay, let's go for evolution of the analytics, which is very important. And I will show one very nice figure you will enjoy to see how value change from the descriptive and how it is difficult. So this is difficult. So as you can see here, I write it down in this figure. I add many texts here. So this made by me, and also this key point that with this explanation, for example, using the Google Analytics to track the thing like website traffic. Here, this is one example of descriptive. You use the Google Analytics to track the thing like website traffic, such as page view and number. This is descriptive. Also, is a data-driven decision, but it's not too much complicated. I put hindsight, so please attention to the keyword. Hindsight refer to understanding and realization of something only after it has happened. It is often used to describe how events or decisions appear clear or more logical when looking back on them. For example, hindsight shows that investigation in that company wasn't a good idea. This is the descriptive analysis. Only after investment of that company, you realize it wasn't the best choice to investing in that company. This is hindsight. So, for example, I can see how my action hurt others. Looking back, you understand the consequence of your action. So, meaning hindsight emphasizes clearly or understanding gain after reflecting on the past event, often involving a sense of regret or lesson learned. So this is very basic of data-driven analyzing. I gave you a very good example. Diagnostic, mining browser data to figure out what caused a peak in the website traffic over the past week. Insight, as you can see here, foresight, amplified intelligence. These four words, which is representative of the, descriptive analysis and diagnostic analytics, predictive analytics, and prescriptive analytics. To understand this one, you will see the evolution of, DDK. So if evolution of the DDK is matched with the evolution of the analytics, evolution of analytics match with the evolution of AI, with all of them, these four words. So what does it mean? Please pause the video and tell me hindsight, insight, foresight, and amplified intelligence. Pause the video and then come back here. Okay. I suppose that you already paused the video and answered to me what are the difference between these four. So let's give you, I made this table made by myself. This is very, very great table. Hindsight is reflective occurring after event. Hindsight. Hindsight means understanding or realization, make a decision, an event when it is occurred in the past. But insight in the present occurred. Foresight means ability to predict in the future. But amplified intelligence means get the benefit of the three of them. Past plus present plus future. Wonderful. This is supporting human cognition with the technology. So this is the real AI for data analyzing using big data plus human intelligence. So this is the DDK. So data plus algorithm, we always said like that. But DDK, DDDK, or 3DK is the human intelligence added. So for each one, you can read the example. With the first side, they investigate in the, renewable energy before a market boom. You cannot use the intelligence, human intelligence only, your feeling. I feel for renewable energy future is feeling. If you should see data, trend, analyze, use big data, AI. So for that one, also descriptive, diagnostic, predictive, and prescriptive. This is the action. Using algorithm for things like price optimization, selling plan, a plan sheet for hotel rooms at the most profitable price. To find you can get many profit. You should use your feeling, your intuition through the amplified intelligence. You got my point? It's very important. Now, this table is wonderful. Really, very nice, very, very nice table. I really enjoy myself. I believe that you also enjoy a lot when you see this table. When I created this table, I enjoy a lot. So this is very important point. And there is one more table I created. Also, I like that one. The difference between analytics and analyze. So many people, they confuse analyze and analytic is same or not. So I created this one. So please pay attention to here to see before we dive into a type of analytics, then quickly we can pass and understand what the evolution of analytics are. So this is very important if you understand this section. So as you can see here, analytics is when we say analyzing means border examination methodology, but when we say analytics means technology driven and advanced statistical methods. So this is the point, the basic point you can talk, and this is the important difference between analyze and analytic. Data handling can work any data size, but when we say analytic, talk on large and complex data set. So process nature often a one-time process, but this is continuously ongoing process. So very technical analytics. So tools, advanced technological tools, various methods you can use when you talk about the analysis. So very general. Scope, extract insight from the complex data. This is general interpretation. So when we talk about the analyze, we should, after that, using that word, we need to say what we mean. When we say, okay, big data analyze, big data storage, big data processing, big data analyze, then we are explaining what we mean. But analytics is very technical terms. Maybe from 400 years ago, history started. And we will start to talk about that one, what happened and what was the history previously talked during the several steps. Complexity, sophisticated, this is simple and sometimes complex. Time frame, continuous, but usually is the project-based, for example, like big data analyzing. So pattern discovery, prediction, understanding the interpretation. So please first understand when we say analytics, do not use analyze. This is the one point which is very important. So in the data-driven, so we start about the traditional, which we explained it based on the gut feelings, but later on we said data and analytics, we want to use it. So type of data analytics, is based on the, so remember when we say data analyze in the decision making, we specify data analyze in the decision making. This is the analytics. So focus what happened, focus why did it happen, use the statistical to forecast the future, and prescriptive recommend action based on the what we desire, human also insight. So let's see more general view of the analytics. So this start analytics value escalator introduced to 2012 Gartner in 4 categories: hindsight, insight, foresight, and amplified intelligence, which is he didn't mention, but which is the optimization in our discussion newly come. But remember, analytics from concept start from long time ago, but this figure 2000 from maybe 300-400 years ago, that is analytics. AI including analytics, big data include analytics, every machine learning during the analytic history. So remember this one, this is as an overview. So when we say descriptive, we already talked, this is talk about what happened by studying past to understand the trends, provide insight into trend based on the past performance. Data aggregation, like data visualization, like sales report, website traffic metrics, tools like Google Analytics. This is descriptive. So in the diagnostic is based on the, by identify root cause of the past, but based on the current, present, to explain the anomalies, to find multidimensional regression. So this is like using the SQL analytics is based on the, not big data, is like structural data. And in the predictive, so that was, we predict based on this, using historical data based on future. And we anticipate, we guess, using some machine learning techniques like scikit-learn, we already work, or Python. And prescriptive is, that is how we recommending a specific action, combining past, future, present, all together, plus human, understanding, intuition, some optimization, decision modeling, which human involved. This is the what the important are. So when we AI and analytics, so the role of AI enhancing data analytics, because if you see AI in the last portion in here play very important, amplified intelligence, and analytics in the as a foundation of AI. Analytics is a long history. AI is 50, 70 years ago. So collaboration of AI and analytics is solving complex problems. Yeah, of course. So now this is more explanation. Analytics refer to collecting processing data for trend. AI refer to simulation human intelligence by machine learning. So amplified intelligence will add to AI, that is the main. So analytics generally fail on 4 categories. AI use various techniques like ML, deep learning, natural processing, computer vision. So you can imagine how these can integrated together. So how AI and analytics will be connected. So in the next slide, you see AI act as a powerful tool to enhance analytics, especially in predictive analytics and prescriptive. AI is important role. Here is descriptive, diagnostic, predictive and prescriptive. Because here AI is very powerful, algorithm getting advanced. Here is AI is very low, algorithm based. So in these two is very important. AI will help to hidden pattern in the large data, which analytics cannot itself manage. So use of AI in analytics. Analytics as a foundation of AI. For AI model to function correctly, they need high quality data and a strong analytical process to prepare the process of data. This is where analytics support AI by providing, AI and analytics are interdependent and complement each other in extracting accurate insight and making better decision making. Why? Because intelligence of AI is very important for analytics. Now, let's see evolution of scientific paradigm. We would like to see what evolution happened in the science. And as a scientific paradigm, we will see how that in the science happened. That is very useful to understand and continue our discussion. I'm prepared those slides and put after this, which will be very helpful. So this is the evolution of scientific paradigm. How science changed from long time ago. When we talk about the science, let's see from empirical science, experiment, then physical law like mechanics, thermodynamics in the second paradigm, and then come to the third diagram, computational science, simulation, many theory like density, functional theory, molecular dynamics. So then come to the big data driven, science. So this is very related our discussion. Let's dive into this section. Yes, very nice. This figure 2022 papers, the review of machine learning, they proposed this one. As you can see, first paradigm is the empirical. Second is the theoretical science. And then computational science is based on simulation. And data-driven, make in the parentheses, big data. When we say data, for example, data, DDDK is the data-driven decision making, DDDM. So this is, we can say BDDM as a big data driven. So this is using the several, third paradigm, this started before, around the, if you see the paradigm, nearly 400 years ago, more than 470 years ago, analytics start. So this figure is also related to analytics. This scientific paradigm and analytics history same. It start from empirical, as you see, it was mostly based on the experience, intuition, gut feeling, and then theoretical, and the computational, and the data-driven. All is the same analytics. So analytics and scientifics, fundamental of the AI, and AI is part of that. See, do you understand? Scientific paradigm and paradigm of the analytics, same. From 70 years ago here, 50 years ago, something totally 400, maybe 70 years ago, history of the scientific paradigm, and 470 years ago, history of the data analytics. Same. See, is it just try descriptive mostly. Here, little bit diagnostic, based on the present, we'll see mechanical thermodynamics, but here do some future science. And then this is more amplify intelligence, AI, pattern recognition, something here. So let's go inside. As you see from John Grant, as a descriptive, statistical analysis, Bombonic plage death based on the empirical observation. Long time ago. Several years ago, the first start from first paradigm, empirical, based on the experience and empirical observation. And then William Playfair created the first bar chart to present a categorical data. 1786. So this is fixed and fit with the analytics. This is my assumption, my way of teaching. You cannot find such a categorizing anywhere. I mix many things together to learn better. You cannot find any book in the world. You cannot find any lecture in the world to explain such a way I am explaining. So you cannot find, they mix analytics, AI, big data, science all together in one slide. You should be very professional to combine. And I recommend you, whatever you learn in different classes, different media mixed together. You cannot find such a lecture in the YouTube or any Udemy classes anywhere. Even I couldn't find in the very top, rank university in the world to teach like AI in this way. This is my, imagination and connection, long time experience and teaching. I brought this together. And remember, when you mix together many things, then you will learn easily. You already know about the science paradigm. Then when mixed with the analytics, AI together makes very interesting things. So unbelievable such a concept when mixed together. Anyway, this type of analytics focus on summarizing historical data. It's a past. So in this paradigm, scientific empirical, collected empirically and based on direct observation, like the example 1960 happened. And another one. So in the patented magnetic detector and horizontal directional aerial, he invented in 90 to 95. Applying theoretical, this is the theoretical science, focus to the law classic mechanics. And from 90 the Einstein just start to talk more than something different from Newton physics, and with the relative theory, try to theoretical science here, and principle of the electromagnetism and signal propagation, and Turing. Remember we had a discussion before, starting 1950, which AI started. Before that, Turing testing 1940. We already discussed before. A theoretical framework to evaluate machine intelligence. Frank Rosenbelt introduced the perception drawing of theoretical. So all is a diagnostic, is a theoretical based. Is diagnosis or analysis aim to identify reason behind a certain event, often based on theoretical model, and explain the system behavior. This is based on the present. And third paradigm is computational science, which started from 1980. So invention of punch tabular data, tabulating machine to create the tabular data, beginning of the era of data processing. Hollich start, and then 1943 Colossus developed the Colossus at the Bletchley Park, a theoretical computer used for the breaking codes by analyzing data. Deep Blue, which was very famous IBM chess playing computer program, which is a 1997. LSTM is the famous, deep learning algorithm, introduced 1997. And Hadoop by Yahoo in 2005. So all is the predictive. So predictive is same computational science and simulation. Utilize computational methods such as Monte Carlo simulation, molecular dynamics. And fourth diagram, last science, we believe they believe that science four diagram. So in that diagram, start from 80. There is no exact date. This is roughly introducing big data driven. Big data started itself 2000, right? But started before BI started, suggested the term of the BI by Miller Devens, these terms in 1965, but followed by Howard Dersent, a similar term in 1989, but focusing using the data and actionable intelligence. So the big data science centers around the data, detection of pattern and anomaly in the large data set, employing AI and data-driven techniques. Like AI development, you remember 1950, introduction of machine learning and GANs as well, 2014 is a, mimic and generic realistic data pattern. And big data emerging around the 2000, that John Massey terms the big data suggested, and then GPT-3 to 2020, this is the fourth paradigm. So this is exactly fit to the, prescriptive analytics. This type of analytics go beyond the prediction by recommending action based on the large data set using machine learning and based on past, present, future, and human understanding, intelligence. Now, let's talk about, I think is enough. We need to little bit talk about the analytics in DIKW paradigm. So that would be helpful for our discussion. Yes, analytics in DIKW. So in the stage one, here in a stage one, data collected. So gather raw data, data containing signal, information, social media. So actively collecting scattered data, outcome basic data. This is equivalent of collected. So this is the collected. And then, for example, a retail company collected the data. So this is the stage one. But here is the descriptive and information as well. So stage two, so in stage one is a collected. So some people said collected part of this, but I consider this is including collected, and this is part of descriptive analysis. So here also part of descriptive analyzing. So better add the descriptive analyzing here. So this is better that this collected also some part of descriptive. In stage two, which is organized, again is a descriptive analyzing. So focus to understand what has happened by the summarizing organization, write data into a structured format. So the objective is data aggregation and data visualization. So we go into a structure and interpretable information that summarize the past event. So this is the descriptive. So until here, we will check the past event in the descriptive analyzing. Stage 3 knowledge is the contextual, means diagnostic, means go beyond the descriptive analyzing by explaining why something happened. Use the contextual analyzing, why certain outcome occurred. So this is the diagnostic analysis, help the company understand why sales, during the specific period. So this is the based on the present. So wisdom and insight, synthesized, predictive analyzing, focus on what is likely to happen in the future using the historical data. So forecast and insight help guide for decision making. So forecast future sale trend as example. And stage one we already discussed, so that's why I quickly passing. We had a mini discussion for optimization and other thing. So this is prescriptive, goes beyond the prediction by recommending action and evaluating potential impact. So this is predictive analyzing. Objective is execute decision-based analytics. So decide, example, what action to take. So if we summarize it, the data, information, knowledge, wisdom. So data and information is the descriptive analyzing, knowledge is diagnostic, and synthesis predictive, and this is prescriptive optimization. So this is a summary of this one. Now let's some question and terms. Okay. So in the analytics, in the DIKW pyramid, some question and terms you would like to see. So the question is here. You already can see. Let's make it bigger. So in the big data is what exists, where it's from. So in the stage 1, a data stage focus on identify, collecting, storing data. So detect, gather, recognize, store, track. What exists, where is from, how is obtained, what signal are being captured, what is missing. So you see here this sort of question. Another is in the second stage, information is a connected, categorized, organized, filter, summarize, who, what, where, how much. The second one here is the descriptive. You know, this figure made by myself, you cannot find anywhere. I bring every concept together. And knowledge, you compare, contextualize, inform by action, analyze, interpret. How did this happen? So many other, like what conversion took place. Wisdom come from at the wisdom inside the stage. Data is synthesized in the deeper inside that guide the strategic decision, synthesize, reflect, open, and apply, embedded with the value and belief. So many questions like, why will this happen? This is predictive, is based on the future, remember? And optimization based on the everything. So you need to consider executed, optimize, refine, evaluate, adjusted. So like what is the best course of action? Human is here, is play is very important. And let's summarize it all. So detect, gather, here connected, in the information here compare, here synthesize, here executed. If we put a simple word. And one more information in the next slide here. This is the last version of the pyramid. Here you can see that value is increasing from here to here. Experience is increasing, and here has a many meaning, data. But when you do process from the data, you will see less meaning. Retrieval increasing. Here is the, based on the algorithmic. This is algorithmic, and this is intuition but rational, this one. And this is intuition rational, these two, for retrieval. Understanding from here to here increase. Recognizing a signal and then identify relationship, this is understand. Extracting pattern, driving the principle, and then refining action. This is now complete version of the pyramid. Consider this is the best version of the pyramid, which cover whole section of all whole classes. So one semester concept I put in one figure. Everything here. It took maybe 3 weeks. I created this figure, change many things, bring many concepts to here, design, redesign, again, to match with everything. Analytics here, AI here, big data here, pyramid here, algorithm history is here. Many concepts related intelligence driven and data driven here. Many contextual improving here. Intelligence relation with analytics here. Algorithm related with data. Wonderful. Wow. Many things here. So you are very lucky this semester that took this class to learn many new things. Never you will find such information anywhere. I promise you that you will not see. Please respect these diagrams. Okay, almost finished. Just few slides for emerging trends and future direction. Some sort of future like data lake, data catalog, edge computing, AI and machine integration, blockchain, distributed ledgers, and quantum computing, data fabric. This is the new wonderful concept. So, for example, data lakes is a large repository of raw data. Hadoop, Amazon, and Azure data lakes is very important new concept. Support diverse of data type and analyzing. This is much support for big data analytics. Data lakes is more advanced from the old big data. This is more advanced big data concept, but this is data lakes is much complicated than that one. So real-time streaming data, like IoT, social media, finance, this is using low latency process, continuous data. So this is real-time insight, decision-making ability to handle high volume. So emerging trend, I think, yes. Evolution of, data, emerging trend and future direction. Like AI integration, automated data processing, when AI and big data combine, although machine learning is part of AI, but more closely work together. Blockchain and distributed ledger. Blockchain is a decentralized. So I had one semester only explain about the blockchain. So Bitcoin is based on the blockchain concept. So when you send the money, there is no bank. In the middle is just based on some agreement. The network is very secure data, and many people can access to encryption. So quantum computing, these days computer is getting small and small. The current computer style, it doesn't work. Should be some change, because as you know that CPU getting smaller, faster until when you want to make it small. After that, then normal computing, it doesn't work. Then you need to quantum mechanics to use for computing. Another is the data fabric and data hash mechanism that handle those sort of data. And AI and we talk about the practice, evolution of data practice. So let's summarize our discussions. That from the manual to the record keeping in the AI assistant, increasing the volume, big data shift from structure to unstructured, automatic way, integrate AI and machine focus about the real-time streaming, and future, which is more ethical issue, which we will explain the next page. So leverage AI for more intelligent practice, unlock new to extract the new insights. And then challenges and ethical issue is very important. Data quality is important. We need to take care of that. Privacy, ethical use of personal data is crucial. So should we, consider for that one. Bias of algorithm, models reflecting bias data leads to unfair. So bias in algorithm and privacy, ethical consideration, ensuring the fairness, accountability and transparency in decision making should be clear. So that's why these days AI, we have a one XAI, explainable AI, means the transparency, because most AI is implicit, right? You don't know inside what happened. When you explain the transparency of the each step, how, for example, ChatGPT giving this result, if the financial issue, if the health issue, we need detail, how you come to this discussion. So then that is the explainable AI would play important roles for that one. So more challenges as summarizing is the scalability, real-time insight, and enhanced personalization. We already talked a lot as an application like NLP, robotic, business, healthcare, urban planning. So majority is for the DDDM is the Netflix and Walmart use the advanced analytics to recommend content to the user, driving 80% of its streaming content. That makes 1 billion save money. So wonderful. So when we say data driven decision making, data is a new oil. So that is very important. Finish. Let's do some recap. What we discussed, we talk about what is the DDDM, data analytics human. And we said analytics, that means part of DDDM is including 4 parts: descriptive, diagnostic, predictive, prescriptive, and then talk about the benefit of the DDM and some challenges we already discussed. Some application we already talked, and some new application which is coming like data lake. Remember, is much new than every concept these days. Edge computing with the AI would be a very important point, and some application. That's all. So we cover DDDM, means data-driven decision making. We try cover everything through several slides. So now we finish all section and all lecture, specifically with lecture 8. Thank you very much for your attention.